everybody. Today we are talking about algebraical expressions. When I'll be using quotations, I'll quote this nice book, Math Steps by Houghton Mifflin. If I mispronounced the name, I'm extremely sorry. You see the cover and the first page of the book on your screen. So our final goal is to be able to solve equations, to be able to use equations in solving word problems, and to cut a long story short, to be able to successfully pass every test which you can encounter. So to do that, we have to discuss algebraic expressions, how and where they come from, and related things. Let us first revise this vocabulary. Exponent, a number that tells how many times a base is to be used as a factor. This is, for example, when we find such a thing as 2 to the power of 3. It means exactly that 2 is multiplied 3 times. This is the exponent. And this is the base. This is the base, and for example, if I write 3 to the power of 10, it means that I multiply 3 10 times. Of course, as you understand, it's much shorter to write 3 to the power of 10. I'm sure you remember that, but I want to be safe, to feel safe in further considerations and deliberations. So, what I wanted to tell you that actually modern maths is about efficiency, speed, and here we see that it's much faster to write this object than to repeat 3 10 times. Power, a number that can be expressed using a single base and exponent. 2 to the power of 3. It's 2 to the third power, yeah. Square root. Well, square root, usually we don't write 2 here, but actually usually we write it like that. For example, square root from 4 is 2. It's an object which, after being squared, gives us exactly what is written here under the square root. Yeah, and we shouldn't forget about plus minus. Actually, there is a trick, we'll discuss it. This is when we only consider plus, it's arithmetic square root, and when this is plus minus, both signs are considered, it is algebraic square root. The rational number is a number that is not rational. The square root of 10 is an irrational number. A rational number is something we can express as a fraction where the numerator belongs to whole numbers and denominator belongs to the set of natural numbers. Those numbers, it's 0, plus minus 1, plus minus 2, and so on. And this is just 1, 2, 3, and so on. Natural numbers. So we can't express any square root which can't be calculated like that. For example, square root from 2 is not a rational number. What I was mostly interested in this revision is monomial and polynomial. Monomial, it's an expression consisting of a number, a variable, or the product of a number and one or more variables. The simplest monomial is, for example, 4x. This is number, and this is variable. Usually we use x as unknown in some equations, but it can be a parameter too. Nothing tells us to use it in one way exactly. A more complex example will be a number, for example, is 10. A squared b cubed. Here we have two variables. One, namely a, is to the power of 2, and b is cubed, so it's b to the power of 3. And this is a product. Even if I don't write the multiplication sign explicitly, this, actually I save myself some time, which it would take me to put those two dots. So this is the common way to write it without any dots, but we assume, we understand, we make this conclusion that this is a product. Otherwise we would write explicitly plus, minus, or some other division sign. So it's a multiplication. So a monomial is an expression consisting of a number, a variable, or the product of a number and one or more variables. Polynomial is an expression that is itself a monomial or is the sum of or product of monomials. So, monomial, that's the example of monomial. And polynomial. For example, both examples in the previous here in the previous item, they are polynomials. But when we add them, 4x plus 10a squared b cubed, this is a polynomial. And it can be a product, for example, x minus 3 and another x minus 4. This is also a polynomial. X squared plus 5x minus 27 times x cubed plus 5x squared minus 7x plus 43 is also a polynomial. All those are examples of polynomials. Coefficient, the numerical factor in a variable expression. Coefficients, here 10, here 4, that's coefficient, coefficient. Constant, the numerical term in a polynomial. So coefficients are constants. We don't call a squared a coefficient because it can be changed. Constant is something that cannot be changed in the framework of this problem. And the final item of our vocabulary is scientific notation, a notation for writing a number as a product of number from 1 to 10 and the power of 10. I'll give you one example. The charge of an electron, it's the smallest charge observable. We don't talk about quarks here in modern physics, just electrons, which gives us electrical currents. And so usually we denote it as E, and it's a negative number, and it's negative 1.6, and multiplied by the power to the negative 19. It means if I write this negative number, I have to write 19, actually 18 zeros. is it an easy task to write 18 zeros? It's not very time consuming, but I can easily miscalculate how many zeros I have already written. So this is the only way to use the elementary electrical charge, the charge of an electron, the charge of a proton, and many other elementary particles. So we find it in modern physics, but first we find it in electricity. So that's the vocabulary, but let me stress again what was the purpose of this short video. I wanted to remind you, or maybe to introduce to you, this very important notion as monomial. It's a number and a part which consists of some letters. It's algebra, and a polynomial is a sum of monomials, or a monomial itself. In a particular case, it's also a polynomial. Okay, in our next video we'll discuss like terms and how to collect and simplify like terms.